Here is example 13 for probability. What is the probability of rolling the same number exactly 3 times with 5 6-sided dice? So one may try to answer this problem with a probability tree diagrams, I should say. However, that might be too complicated because there are many cases to cover and that might be a little bit messy. So here, I'm going to show you a demonstration using a setup. So imagine 5 dice right here with 3 of them having the same number. Let's just mark them with A. And then the other 2 will have like any other number except A. Now since we have set A to be our fixed same number in this case, its probability of occurring will be 1/6. Same with here 1/6 and same here with 1/6. Now since here the dice marked with B will show a number other than our dice in A, its probability will be 5/6, which is the complement of 1/6. So one may say we can just multiply all these probabilities out. However, we haven't covered the order that they could occur. So what I mean by that is that we can have our dice marked with A first, and then we have 2 B's on the middle and with another A on the end. Similarly, we can have A, we have B right here and B right here. I guess we have 2 A's on the end. And there could be many possibilities here. However, instead of covering all the cases and just counting them manually, notice that this is just the same as sorting out 3 kinds or three same kinds. In this case, marked with these 3 A dices or 3 dices marked with A out of 5 things. And the number of ways to do that is actually 5 choose 3, where this means this is actually called the binomial coefficient, and it is defined as 5 factorial over 3 factorial times 5 minus 3 factorial. So this is actually the number of ways that you can sort of 3 things out of 5 total things. So this is usually defined as N choose R, or usually probably some other notations like N CR probably. However, I'm going to refer this as this notation right here. So in algebraic form, this could be defined as N factorial over R factorial times N minus R factorial. So there we go. Now you can calculate this on your own. And then after this, we can just multiply whatever this number is into the product of these probabilities here. And then we're not really done yet because we see that A could be any number from 1 to 6. And if we only covered one of them, we still need 5 others to go. However, this can be quickly solved by multiplying a 6 in front of our expression. So our ending expression will look something like this. So here we have 6 times our binomial coefficient 5 choose 3 times, since there are 3 1/6, we can represent this with 1/6 cubed times 5/6 square. And then I will leave you guys to calculate this on your own. Now, if you guys have learned about like advanced probability or advanced statistics, you may know that this is the expression of a binomial distribution of probability. And this ends this video.